Okay, the question asks us to find the antiderivative of this function right here. And partial fractions is the way to go. Here's f of x, this quadratic polynomial divided by x cubed plus x, or x times quantity x squared plus 1. Here's the partial fraction decomposition of that function, 4 over x plus minus x plus 4 over x squared plus 1. And here's how you can do that. This is an irreducible binomial here, irreducible quadratic. So its form will be bx plus c over x squared plus 1. And if we multiply it through by the LCD, we get this, and it's easy to solve for a, b, and c by equating coefficients. So a plus b has to be the coefficient of x squared, c has to be the coefficient of x, a has to be the constant term. So these are easily found. And that means b has to equal minus 1. So, and this table kind of proves that that partial fraction decomposition is correct. I picked selected values of x and they equate to the same values. Okay, so what we want to do is find the antiderivative of a function that looks like that. It's just the p of x instead of little f of x. So what we'll do is break this apart into actually three separate integrals. This will be integral of 4 dx over x. Here we're going to divide x squared plus 1 into each term of the numerator. And I'll put the minus sign out front for this term. And we can use u substitution for this. Let u equal x squared plus 1. Then du equals 2x dx. So we have to put a 1/2 out front. And then we've got the antiderivative of du over u, which is ln of u. I didn't put the absolute value symbols here because this is guaranteed to be a positive number. And then when I divide x squared plus 1 into this 4, I can move the 4 out front, and the antiderivative of this is inverse tangent. Okay, so there's your antiderivative. And here's a way to kind of prove it on Desmos. Here is our answer, big F. And if I take the derivative of big F, I should get little f. And if I graph f prime of big F and little f of x at the same time, the graphs are identical. So that kind of proves that this is the answer. Okay, and I'll provide the link to this Desmos graph so you can confirm. There you go. Hope that helped. If you have any questions, post a comment.